मैम ट्रांसफॉर्मर हमारे सिलेबस में नहीं है ना?
नहीं है।
ठीक
Okay. Okay. Now, electromagnetic induction. Now, we have read that when an electric current is passed through a conductor, a magnetic field is produced. ये हम पढ़ रहे हैं. Okay. Now, Faraday thought, like since a magnetic field is produced by an electric current, it should be possible to produce an electric current by the magnetic field. Okay. So he's saying that when we have a magnetic field and when we have some mechanical force, हम पढ़ने वाले हैं, then there should be a possibility of generating electric current. Okay. So he performed a number of experiments and observed that whenever there is a change in the number of magnetic field lines linked with a conductor, an EMF is developed between the ends of the conductor, which lasts as long as there is a change in the number of magnetic field lines. This phenomenon is called electromagnetic induction. Now, इसमें से we will just separate it out. Now, whenever there is a change in the number of magnetic field lines, change मतलब क्या? Like see, now we need to presume that the magnetic field lines are coming out as straight line. Okay, like this way, ऐसा arrow. So these are magnetic field lines. So whenever there is a change in magnetic field lines, like for example, सुनो ध्यान से सुनो, हाँ, like एक टाइम पे 10 है. Okay, so there is a 10 magnetic field lines. थोड़े देर बाद it will be 5 magnetic line, then 0, then 5, then 10, ऐसा, then again 5, then 0. That means whenever there is a change, okay, whenever there is a change in the number of magnetic field lines, that time EMF is generated. What is an EMF? It is the potential difference across the conductor. If you remember, current कब flow होता है? Current electricity में हमने पढ़ा था. Whenever there is a potential difference, like एक जगह पे 10 volt होगा तो दूसरी जगह पे 0 होगा. So 10 to 0. So whenever there is a potential difference, okay, you will be having current. So what Faraday is saying, whenever there is a change in the magnetic field lines, ऐसे मतलब पहले 10 field lines जा रहे थे, अभी 2 आ रहे हैं, फिर 1 आ रहा है, फिर 0. मतलब whenever there is a change, that time an EMF is developed. And when EMF is developed, that means the current is generated. Because EMF is developed का मतलब होता है that you are creating the potential difference. So whenever there is something high and something low, तभी current आएगा ना. Because current is from what? High to low, according to convention. Okay. तो ऐसे बोलोगे तो high to low मतलब when there is more flow of electrons, मतलब electron का number high है, that time also the current is flow. So it is always from high to low. Okay. So what is this experiment? इतना समझा आपको? So whenever there is a change in the number of field lines linked with a conductor, and EMF is developed between the ends of the conductor. Ends मतलब समझ में आया? Like A और B, like दो points पे तुमने measure किया, you will be able to see that yes, there is a potential difference, and yes, if you have a potential difference, then there will be a current. Now demonstration, this is a very interesting. मेरे पास एक वीडियो मैंने रखा है, देखते हैं if you can see. Now
मैम ये डेमोंस्ट्रेशन का तो पेपर में नहीं आएगा ना?
हाँ, but this is very important to understand Lorentz, what do you say, Lenz law.
Okay. नहीं मैं बस बता रहा हूँ, पूछ रहा हूँ कि नहीं आएगा ना?
नहीं, कोई भी नहीं आता है. None of the experiment is going to come, okay? But if you don't understand, ऐसे ही जाके तुम अगप करके लिख सकते हो पेपर में. Okay. Now wind an insulated copper wire in the form of spiral on a paper. मतलब ऐसा hollow करके रखो, okay? So it's like आपने एक cylinder बना के रखा, okay? So imagine a cylinder, okay? Cylindrical paper, ऐसा सोचो. So paper cylinder है, so as to form a coil in the form of a solenoid. और तुमने क्या किया? पेपर सिलेंडर के ऊपर ना वायर वाउंड करके रखा. ओके, नाउ यू आर कनेक्टिंग अ सेंटर जीरो गैल्वेनोमीटर. नाउ डू यू रिमेंबर व्हाट इज द पर्पस ऑफ गैल्वेनोमीटर?
Direction. Detect the presence of weak current.
Yes, detect the presence of weak current. Just one second, huh? Someone has come. Nitin. Okay, now connect a center zero galvanometer between the two ends of the solenoid. Okay, then place a magnet. Can you see a magnet north south? So place the magnet north south at some distance along the axis of solenoid. So basically try to move this magnet inside and outside. So this is a spiral. Okay, this is a spiral. So you are trying to move the cylinder inside and outside. So you are just trying to move it, huh? Okay, so place the magnet at some distance along the axis of solenoid. Okay, now when the magnet is stationary, that means when you are not moving the magnet, what is happening? There is no deflection in the galvanometer. Okay, That means when there is no movement of magnet, no deflection in galvanometer, that means there is no current. Okay, so first observation ho gaya. Now second observation, when the magnet with its north pole facing the solenoid is moved towards the galvanometer, it is showing the deflection towards right. So when you are moving the magnet towards the solenoid, you are able to see the deflection towards right. Okay, and when you are moving, then there is a deflection. After the movement, you stop it. Okay, you stop the magnet. Again, the deflection will become zero. Again, you try to take the magnet away from the solenoid. Again, you will be seeing the deflection. Okay, now you change the direction of the magnet. So when you change the direction of the magnet, like south to north, and you are trying to pull it towards it, again you are seeing the deflection. That means what are you trying to interpret from this? Can anyone tell me? That whenever there is a movement, okay, whenever the magnet is moving towards the solenoid, there is a current. Okay, whenever it becomes stationary, see, whenever it becomes stationary, there is no deflection in the galvanometer. Did you understand? Now let's understand the current's direction. Okay, so when the magnet with its north pole facing the solenoid is moved towards the galvanometer, it shows a deflection towards right. Okay, now what happens when you are trying to push, or you can say you are trying to place the magnet towards the solenoid? What happens? This side of the solenoid becomes north. Okay, why it becomes north? Because it is trying to oppose it. Yeah, see, when, remember always, when the north, you are trying to push the magnet towards that, what happens? This place becomes north. Why? Because it is opposing. Okay, so work done. नहीं तो देखो ना, ये south बन गया, सोचो ये south बन जाता तो क्या हो जाएगा? This magnet will go and stuck with it. But it doesn't happen that way. You are trying to move it. Okay, so when you are trying to move it towards it, this side will become north pole. Okay, and the other side will become the south pole. Now, if you notice the direction of the current, direction of the current is from the south to north. Okay, now when you make it stationary, what happens? There is no current. When you're trying to put the magnet away from the solenoid, what happens? You are going away, then it will try to become south, and the current direction will be interchanged. Did you observe this? Again, when you're trying to move south towards this side will become south. Okay, fine. And always notice the current flow is from south to north. Okay, यहाँ पे भी देखो, south to north, south to north. Okay.
Ma'am, why does it become south?
There is a reason for it. Okay, so for you, see, this you will be getting it.
I mean, वो same poles क्यों हो जाता है?
Okay, now same poles क्यों होता है? So we have a Lenz's law. There is a Lenz's law. Okay, that is the reason, huh? So according to Lenz's law, the direction of induced EMF is such that it opposes the cause which produce it. Okay, so देखो यहाँ पे, when north pole of the magnet is brought towards the end A of the solenoid, the induced current flows in solenoid in direction B to A. Okay, that is at the end A, the current is anti-clockwise. If you remember, हमने पढ़ा था, at the face, at the when the pole is north pole, what will happen? The current becomes anti-clockwise, and when it is south pole, the current becomes clockwise. You remember, हमने पढ़ा था, the current is anti-clockwise, so the end A of solenoid becomes the north pole to repel the magnet. It is trying to oppose it. See, if it becomes south pole, what will happen? It will try to attract the magnet. That is not possible, na? You are trying to just ऐसे तुम हिला रहे हो, ऐसे आगे पीछे कर रहे हो. Okay, so when north pole is brought towards the end A of solenoid, the induced current in direction from B to A. So if you notice, यहाँ से देखो, the current is from B to A. Okay, so when the current is from B to A, ये क्या हो जाएगा? What is this happening? This is anti-clockwise, है ना? Can you see the anti-clockwise direction? B to A, just observe it like a clock. B to A is an anti-clockwise. Therefore, this end becomes north pole, so that it can repel. Thus, it opposes the motion of the north pole of magnet towards the solenoid, which is the cause of producing it. Okay, thus it opposes. So it doesn't allow. So you are trying to force the magnet towards the solenoid, but the end of the solenoid has become north pole. Therefore, you are trying to oppose the motion. Okay, you are trying to repel it. See, if you don't try to repel it, what will happen? It will see, you are supposed to generate a current. Okay, so whenever there is a motion in that magnet, that time the current will be induced. Okay, so again, when the north pole is brought towards the end, the induced current starts flowing from B to A, and the current is anti-clockwise. So the end A of solenoid becomes a north pole to repel the magnet. Thus, it opposes the motion of north pole towards the solenoid, which is the cause of producing it. Okay. Okay. Next one, when the north pole recedes from end A, that means you are trying to take out the north pole away from the solenoid. What will happen? The direction of induced current in the solenoid is B to A. Just 1 second, huh? Please, yaar, pick up the phone and the direction of induced current in the solenoid is from B to A. So let's notice that. If you are trying to recede the north pole, I think wahan pe mistake, it will be from A to B. It will be from A to B. Okay, you are taking away, then it will be from A to B. Okay, so it is clockwise at the end A. So it becomes a south pole. Now, whenever you have a clockwise current, then that side will become south pole, so as to oppose the motion of north pole away from the solenoid, which is the cause of producing it. So Lenz's law is based on the law of conservation of energy. It shows that mechanical energy spent in doing work against the opposing force experienced by the moving magnet is transformed into electrical energy, due to which current flows in the solenoid. So always remember, okay, so there is a force, okay, and if you are doing against that force, if you are doing work against that force, okay, या तुम ऐसे सोचो एक कोई फोर्स है and you are trying to move one charge, जैसे हमने पढ़ा था ना potential difference में, what was potential difference? It is work done in moving a positive charge from infinity to a point. Okay, मतलब तुम जबरदस्ती का एक चार्ज उठा के वहां से एक from infinity to a point, you are trying to drag it. Okay, so you are doing work, that is called what? Potential difference. So same thing, when you are spending an energy in doing work against the opposing force, that thing will get converted into electrical energy. Okay, so again I'm repeating, mechanical energy spent in doing work against the opposing force, okay, experienced by the moving magnet, is transformed into electrical energy, due to which current flows in solenoid. Okay,
Yes, ma'am.
ठीक है, so that's called Lenz's law. That's the Lenz's law. So according to Lenz's law, so exam में क्या आता है Lenz's law में? Only this part will come. They will be asking you state Lenz's law. The direction of induced EMF is such that it opposes the cause which produces it. Okay, I hope you understood. More in depth you will be studying in 12th. Okay, so conclusion is, from the above observation, Faraday made following 3 conclusions. Okay, current flows in the coil only when there is a relative motion between the coil and the magnet. Okay, so whenever there is a motion between the coil and the magnet, that means, see, you can do one thing, either you move the magnet or either you move the coil. Okay, you will be getting a current. समझा क्या? Either you move the coil or either you move the magnet, you will be having a current flow. Now, how can you have direction of the current is reversed if the direction of the motion or polarity of the magnet is reversed? Okay, if you see here, see, initially the current was flowing from B to A. Next time the current was flowing from A to B. What do? When you change the direction of motion, now initially it was towards it, so the current was flowing from B to A. Then after that, when you are trying to move it away from the solenoid, then the current is flowing from A to B. If you change then another way, how can you reverse the polarity? If you change the magnet position, okay, if you change the polarity of the magnet, still you will be seeing the current flow in a different direction. So there are 2 ways to change. One is the direction of motion, and the second is change the or reverse the polarity of the magnet. समझा आपको? अनुष्का, एनी डाउट?
No, ma'am.
ठीक है, so how can you change? One is change the direction of motion, or you can change the polarity of the magnet. Okay, how can you increase the current? If you increase the motion, but if there is a rapid motion of the magnet, okay, then also you can increase. Then if you use a strong magnet, then also you can increase. Or if you increase the area of cross section of coil, or you can increase the number of turns in the coil. Okay, यदि तुमने ज्यादा number of turns किया, then you can increase the current. Okay, fine. So when there is no motion between the magnet and the coil, okay, now we are going to study a new thing. Okay, we understood that there is something called magnetic field lines. Okay, so let's understand now what happens when there is no motion between magnet and the coil. The total number of magnetic field line passing through the coil remains constant. Okay, like for example यहाँ पे देखो. Okay, just observe here, or you can say just observe this. Now the magnet is there in front of solenoid. Okay, that means there will be some magnetic field line which is passing through the solenoid. अरे magnet तो बाजू ही रखा है ना, तो therefore the magnetic field lines will be there, but magnetic field lines will be constant. मतलब सोचो इसमें से ना 10 एरो निकल रहा होगा, ऐसा इमेजिन करो कि देयर आर, ओके, 10 निकल रहा था, ऐसे 10 magnetic field lines are coming out from this magnet. Okay, but it is stationary, it is constant. So when it is constant, when the number of magnetic field line is constant, there is no current induced. Okay, induced मतलब क्या? What is the meaning of induced? Induction, conduction, induction. Without touching, you are able to induce the current, na? There is no physical contact, still you are able to induce the current. Did you apply any circuit? Atharva, Ayush, Pranav?
No, ma'am.
So what is the meaning of induction? You are able to induce a current without any physical contact. See, you are not having anything, still the current is getting induced. That means it is getting generated without any physical contact. That's called induction. Okay, so when the magnetic field line is constant, there is no current, no current is getting induced. When you are changing the magnetic field lines, now you are trying to move closer to the solenoid, तो क्या होगा? पहले 10 आ रहे होंगे, सोचो 10 magnetic field lines आ रहे होंगे, और अब ना 15 आने लग गए. Okay, so initially it was 10, now it is 15. So whenever there is a change, that time the current is getting induced. Now again you come forward and you get stopped, then क्या होगा? Now the magnetic field line is 15, now there is no change, so current is stopped. Again you are taking away the magnet, तो क्या हो जाएगा? The magnetic field line is reduced. तो पहले 15 था, अभी 10 हो गया. So whenever there is a change, the current is getting induced. ठीक है, समझा आपको अभी?
Yes, ma'am.
So total number of, so normally please don't think that magnetic field line is zero. No, it is not zero, it is constant. Okay, total number of magnetic field lines of the magnet passing through the coil. Okay, now what is the meaning of magnetic field lines passing through the coil? So there is a word which has been introduced, that word is called magnetic flux. Magnetic flux का मतलब यही होता है, magnetic field lines. Okay, तो उसको ही बोलते हैं linked with the coil. Okay, so when the magnetic flux remains constant, no EMF is induced and no current is flow. When there is a relative motion between the coil and the magnet, जैसे दिख रहा है यहाँ पे, magnetic flux linked with the coil changes. Okay, the coil is moved towards the north pole of the magnet, thus magnetic flux through the coil increases. Similarly, if the coil is moved away from the north pole, the magnetic flux is decreases. अब बार बार वो magnetic field lines ना बोल के, they have coined a word called flux. Okay, so due to change in the magnetic flux linked with the coil, an EMF is induced in the coil. The induced EMF then causes the current to flow in the coil if the circuit of the coil is closed. अभी यहाँ पे ये सोचो, this end was not closed, it was open, तो current flow नहीं होगा, but yes, there will be induced EMF. यदि तुमने वहां पे एक, यहाँ पे उन्होंने क्या लगाया, गैल्वेनोमीटर, यहाँ पे तुमने एक बल्ब लगा दिया, you will be able to see the bulb is glowing. Okay, so if there is a closed circuit, you will be able to see current is flowing. समझा आपको? So what is electromagnetic induction? It is a phenomenon in which an EMF is induced in the coil if there is a change in the magnetic flux linked with the coil. Okay, if there is a change in the magnetic flux linked with the coil. You have to write this definition, no other definition. Okay. So what is electromagnetic induction? The mechanical energy spent. Okay, so there is a energy spent. आपने काम किया है ना, मैग्नेट को कॉइल की तरफ लेके आया या कॉइल से दूर लेके गए. There is a work done. Okay, so the mechanical energy spent in moving the coil, okay, in moving the coil or the magnet to change the magnetic flux, that is getting transformed into electrical energy in the form of current in the coil. ठीक है? So basically what is the conversion you are trying to do? यहाँ पे किसका conversion चल रहा है? Anyone? What was DC motor conversion? DC motor का conversion क्या था?
Electrical to mechanical.
Yes, electrical to mechanical. And what about this? यहाँ पे क्या चल रहा है? It is mechanical to electrical. See, you are trying to move it. You are trying to move the coil or you are trying to move the magnet. Okay, and that mechanical energy is getting converted to electrical energy. So in induction, in EMI, electromagnetic induction, mechanical energy is getting converted to electrical energy. Okay, समझा आपको? I hope you understood.
Yes, ma'am.
So what are the two, so what is the basically two laws? Now Faraday has made two laws. Okay, so whenever there is a change in magnetic flux linked with the coil, again and again I'm saying magnetic flux क्या होता है? Magnetic field lines को ही magnetic flux बोलते हैं. जैसे initially 15 है, 10 है, 5 है. So whenever there is a change, okay, EMF is induced and the EMF induced will last as long as there is a change. जब तक change रहेगा तब तक EMF होगा. Change बंद हो जाएगा, EMF बंद हो जाएगा. Okay, magnitude of EMF is directly proportional to rate of change of magnetic flux. What is the meaning of rate of change of magnetic flux? तो इन्होंने ना ये नहीं दिया हुआ है. I will just give you a formula, not necessary for you. So ऐसे सोचो, so induced current, okay, or you can say induced EMF, okay, it is delta. मैं delta को ऐसे नहीं लिख रही हूँ. I hope you know what is delta. Triangle होता है ना, triangle वो. So delta phi लिखते हैं, तो मैं यहाँ पे क्या लिखूँ? मैं क्यों लिखूँ? Okay, delta phi होता है, मतलब basically I'll draw the thing. मतलब phi कैसे लिखते हैं? ऐसा होता है phi and ऐसे कट करते हैं. Okay, so this is called phi. So it is change in magnetic flux. तो इसको phi बोलते हैं, phi. PHI, phi बोलते हैं. So induced EMF is rate of change of phi. So phi ना लिख के मैं यहाँ पे Q लिखती हूँ upon dt. Okay, so it is a rate of change of magnetic flux linked with the coil. तो Q के जगह पे imagine this is the symbol. ठीक है? Did you understand?
Yes, ma'am.
Okay, now if the magnetic flux is changing at a constant rate, मतलब ऐसा सोचो हर एक सेकंड में magnetic field lines change हो रहा है हर एक सेकंड में, so then you can have a steady EMF, एकदम proper EMF मिलेगा. And if you have proper EMF, steady EMF, you will be having steady current. Okay, now can anyone tell me which type of current is coming inside our home? Is it AC current or is it DC current?
AC.
Yes, through mains it is coming AC. Okay, now factors affecting the magnitude of induced EMF you already studied. So factors are what? Rate of change of magnetic flux with each turn, okay, and number of turns. So जितना तुमने number of turns increase किया, what will happen? EMF will be more, okay, and the current will be induced more. So there are only two factors to change the induced EMF. One is change the rate of change. जैसे अभी हो सकता है कि 1 सेकंड बोला, हो सकता है मिली सेकंड में ये करो, ओके, माइक्रो सेकंड में करो, मतलब इतना फास्ट करोगे अपना मैकेनिकल एनर्जी, यू विल बी एबल टू गेट स्मूथ करंट, ओके, और यू कैन इंक्रीज द नंबर ऑफ टर्न्स इन द कॉइल. दिस विल बी मोर कॉस्टली, दिस इज मोर कॉस्टली नंबर ऑफ टर्न्स इंक्रीज करने के लिए, बिकॉज इफ यू नो एक बार ही इंस्ट्रूमेंट बन जाता है, वो इंस्ट्रूमेंट में जाके बार बार खोल खोल के यू विल नॉट ट्राई टू इंक्रीज द नंबर ऑफ टर्न्स, ओके, यू विल ट्राई टू चेंज द रेट ऑफ मैग्नेटिक फ्लक्स, मतलब तुम थोड़ा सा फास्ट हिलाओगे चीजों को. Okay, any doubt in this case? Now how can you determine the direction of induced EMF? Now direction of induced EMF depends on whether there is an increase or decrease in the magnetic flux. Okay, याद रखना, मैंने बोला ना, अभी मैंने जो बोल रही हूँ वो सुनो, 10 5 0 5 10. देखो मैंने क्या किया, सोचो इनिशियली देयर इज 10 मैग्नेटिक फील्ड लाइन, उसके बाद वो क्या हो जाता है 5, then it becomes 0, then it becomes 5, then it becomes 10. ओके, तो इंक्रीज और डिक्रीज, मैं क्या कर रही थी पहले, डिक्रीज से इंक्रीज किया. सो व्हेनेवर देयर इज एन इंक्रीज और डिक्रीज कंटिन्यूअसली, ओके, दैट टाइम यू विल बी एबल टू गेट इंड्यूस्ड ईएमएफ. तो फ्लेमिंग्स राइट हैंड रूल एंड लेंस लॉ. लेंस लॉ तो तुमको समझ गया. आई ऑलरेडी एक्सप्लेन्ड यू लेंस लॉ. ओके, कि जहां से करंट फ्लो होता है, सो व्हेन इट इज व्हाट यू से एंटी क्लॉकवाइज, दैट एंड विल बिकम नॉर्थ पोल. ओके, नाउ लेट्स अंडरस्टैंड फ्लेमिंग्स राइट हैंड रूल. ओके, नाउ सब लोग अपना अपना राइट हैंड करो एंड सब लोग अपना वीडियो ऑन करो. चलो चेक दी. ओके, right hand low. Now this is the thumb is the motion of the conductor. Okay, the middle finger or you can say the index finger is what? Just 1 second, I want to check कि कोई भी नहीं ऑन कर रहा है क्या? Okay, no one is able to at least on. मेरे को देखने तो दो तुम लोग कर क्या रहे हो. Okay, good. Now motion of the conductor